So myself, Srinivas, working as a faculty in the Department of Mechanical Engineering at Sri Sharma College of Engineering and Technology. To overcome the issue of vanishing gradient in RNN, we use certain strategies. The strategies are leaky and skip connections and drop. So why RNN fail? Because of the vanishing gradient, as I said, and we can't handle the long range dependency. Because in the long range, in the sequence, we come across many important and unimportant informations. So to overcome this vanishing gradient and overfitting issues in a simple RNN, we can use these three strategies. Okay, the first strategy is basically leaky unit, and second strategy is for the skin connection, and this third one is dropout. So these three strategies can be implemented to overcome the vanishing gradient issues. So this is expression for the simple RNN. So this is basically your linear combination of vectors. This is the activation function that we use here. So this is hidden state at time t, and this is for the single time step. This is for the single time step. Okay, and this is for the long range. So if you look at this expression, dou ht by dou ht is equal to, this is for the it varies from k to t, and it is a product of many gradients. So that's the reason it is being used for the long. This expression shows that it is used for the long ranges. So in the leaky unit, what we do here is that we keep some parameter that is called leaky parameters, and that takes care of how much old information has to be kept. So that controls that controls in the unit. Basically, if you look at this is for the current memory. This is for current memory. This is for the old memory. This is for the new informations. So this is simple RNN. Okay. So even when you go for the gradient and if the time is going to be 0, and even though we'll have these alpha values. Okay. So that is the reason it doesn't allow the network to become 0. Okay. So there will be some sort of learning will be there that takes care of these parameters called leaky parameters. Another one is skip connections. And so instead of going for every time steps, we don't update every time steps. Instead of that, we can update certain time steps, and that takes care of this long range dependency. So that is the idea of skip connections. This has been widely used in this is being used in attention mechanisms. So the previous leaky unit that is being used in LST, but is a particularly people use in GIU. So in this skip connection, it is widely used in that we come across in many attention mechanisms. Okay. So this is the hidden state. This takes care of this is our normal RNN output. Okay, this is one we use here. So this is activation function. This is a combination of vectors. So this is a one we get. So in the old one, we have this gamma function over here. That is skip here. Okay, so that is the reason it doesn't go by every time steps. It skips few things, and it takes care of in this competition that takes care of the vanishing issues. Because since it skips many time steps, as a result, it can the gradient instead of 100 time step, it will take care of 20 times. So as a result, that it doesn't allow the network to become 0. So this is a function that we use, and basically even if you differentiate with previous time steps, so from t2 minus t2 scale time steps, then what happens, you will have this gamma value. So it doesn't allow the vanishing gradient doesn't allow the network to become 0. So that is advantage in the earlier one, and the earlier leaky unit, the alpha takes care of the past history. Here it doesn't consider all the time steps, it considers only few time steps, That will take care of the long range dependencies, as well as it doesn't update, it differentiate the important and unimportant informations. So the next one is basically a dropout RNN. Dropout is basically that we come across in deep learning, that basically it deactivates certain neurons in the architectures. So similar thing, it is a similar thing. It is used. It is being done in RNN, and it disables the neurons, and as a result, it doesn't. If it disables, now as a result, it will have stability. It will make the architecture to have stability as well as less overfitting issues. So how it has happened? Because it uses these parameters called, this is a m value. The m is basically a based on the knowledge distribution. And this is either you have two outcomes. One is p is equal to 1 and p is equal to 0. Then if it is 0, then it is disable the network, and if it is 1, it is activating the network. So the same mask is used across all the time steps. This is the one we use here. So the basic idea behind these three strategies are, so Leaky RNN, basically it has the how much we have to keep, that is the idea of this, and that can be used in our LSTM architectures. And skip connection is basically, it doesn't consider all the time steps, and it takes care of the long range dependencies. That's why it is mostly used in items and mechanisms. And dropout is basically, as we discussed, it is used in most of the modern RNN architectures. It takes care of this overfitting issues and stability. So these are the three strategies one can use in simple RNN to overcome this vanishing gradient issue.